Our next lesson is dividing radicals and rationalizing the denominator. Today we're going to look at the quotient property of square roots. And the quotient property says that if you have the square root of a over b, that's a fraction, you can break that into two separate radicals. You can take the square root of a separately divided by the square root of b. All right, remember that a radical is in simplest form if there are no perfect squares other than 1 in the radicand. Remember, there can be no fractions in the radicand, and no radicals are in the denominator of a fraction. Okay, so let's get started. All right, you can see problem number 1 has the square root of 3/4. So what you're going to do is you're going to break that into two separate radicands. So you have the square root of 3 over the square root of 4. So that's your first step, is to break it into two different radicands. And then you can see that you can actually take the square root of 4, that would become 2, and then the square root of 3 would stay the same. So remember, your goal is to simplify as much as you can, and that would be a simplified radical. We're going to do the same thing to number 2, so I'm going to take radical 175 on top, and then I would take radical 36 on the bottom. Now I need to simplify each different radical. The bottom I can see easily is going to be 6, and then the top I need to break it into I need to find the largest perfect square, which from previous problems I know is 25 times 7. Those are the two factors. That's the largest perfect square, is 5. Then I simplify the numerator, and I would take the square root of 25, that would be 5, and leave 7 inside the radical. Then I would put my 6 on the bottom as my denominator. Now, it's perfectly okay for me to have a radical in the numerator, but I cannot have a radical in the denominator, so this is simplified form. And I cannot have a fraction inside the radical, so I'm okay. All right, let's look at number 3. Again, we're going to break this into two separate radicals. So radical 25 on top, then radical 49 y squared. Well, I can see I've got some perfect squares here, so this is going to be pretty easy. The top just becomes 5, square root of 25, and the bottom, the square root of 49 is 7, and the square root of y squared is y. So now I have a simplified radical. Okay, next. Next I'm going to do the square root of 24, x to the 9th, and the square root of 3, x to the 3rd. Now notice that these have already been split up into two different radicals. So what I can do, because it's division, is I could actually divide, just like when I was multiplying, square root of 5 times square root of 5, if I multiply that together, I get the square root of 25. Well, I can do the same thing if I can divide evenly. I can divide the 24 by 3. So I take the square root of 24 divided by the square root of 3, and that would give me an 8, because 24 divided by 3 is 8. And then I can take x to the 9th divided by x to the 3rd and subtract these exponents to get x to the 6th. Now I know that this is not simplified, so then I would need to simplify. So again, divide and then simplify. And this breaks down into the square root of 4 times 2, and then I have to take the square root of x to the 6th. So the square root of 4 would be 2, so I'm left with 2 radical 2, and then the square root of x to the 6th would be x to the 3rd. Now if I put it all together, I'll just put it over here, it would be 2 x to the 3rd radical 2, and that would be my answer. Okay, so let's do a few more. You can see on these next two problems I have the square root of 96x divided by the square root of 6. So I can divide 96 divided by 6, and I would get the square root of 16, and then I would have an x. And then on the bottom I would just have a 1. So I can easily see that the square root of 16 is 4. I cannot take the square root of x, so that would be my answer, and I don't need to write the 1 in the denominator. All right, last one in this part. It's not the end of the video though, so don't quit on me. I would take the square root of 63 divided by 7, so 63 divided by 7 would be 9, and x cubed divided by x1, you subtract and you get x squared. Then this is easy because these are perfect squares. The square root of 9 is 3, the square root of x squared is x. So there's my answer. Now there are some times when you cannot divide like this, and you're just left with a radical in the denominator. And you're not allowed to leave a radical in the denominator, so you have to do what we call rationalizing the denominator. So the next section is on that. Okay, so the next section here is we have radicals in the denominator that we cannot divide into the numerator. So to rationalize the denominator, you're going to multiply both the numerator and the denominator by the radical that's in the denominator. And that's called the identity property because you're really multiplying by 1, and I'll show you that in a minute. And then you must simplify completely. So for example, here you have the square root of 1/5. Well, the quotient property says that we take the square root of 1 and put it over the square root of 5. Well, you can't really divide 1 by 5, and you can't leave the square root of 5 in the denominator. It's okay to have the square root of 1 on top, but you cannot have a radical in the denominator. So what you do is you multiply by the denominator, square root of 5, and whatever you do to the bottom, you must do to the top. So we're going to multiply by the square root of 5 over the square root of 5. Now anything divided by itself is 1, so this is really just a fancy way of saying 1. You're really just changing the format of the radical. Alright, so if I do the top, I get the square root of 1 times the square root of 5. That's going to be the square root of 5. And then on the bottom, I get the square root of 5 times the square root of 5, which is the square root of 25. Now I have a perfect square in the bottom, and I can then just keep the radical 5 on top, but then I would have a 5 or an integer on the bottom. And now this is a simplified radical. Okay, same thing for number 8. First, you break it into two problems. You have radical 5 over radical 3. And now you can't divide those two numbers, so you'll take whatever the denominator is, and you'll multiply by the square root of 3 over the square root of 3, which is the identity property. It's just like multiplying by 1. Then on the top you'd have radical 15. On the bottom you have radical 9. And now, can you simplify radical 15? Are there any perfect squares in there? No. So that stays the same, but the square root of 9 is 3. And then this is a simplified radical. Do the same thing for number 9. So I don't have to do any square roots. It's already been broken down. So the only thing I need to do is multiply the denominator and the numerator by the square root of 5. So I'm going to do that. So now I multiply across. Now this is an integer, not a radical, so it just becomes 10 radical 5 on the top. And then on the bottom you have radical 25. Now to simplify, you would get 10 radical 5 on top, and then you would get 5 on the bottom. Well, now you can see that this is a fraction, 10 over 5, and 10 divided by 5, 10 over 5 reduces to 2 over 1. So 10 divided by 5 is 2. So I get 2 radical 5 over 1, but I don't need to write that, and that's going to be my answer. So you must reduce. This is like a fraction. You must reduce that. All right, the last three problems. So again, we're going to do it the same way. Radical 7 over radical y. So then I must multiply by whatever the denominator is. So radical y over radical y. So then I'm left with, if I multiply those together, they're both inside the radical, so I get 7 radical y over radical y squared. Now I can simplify the denominator, but the numerator will stay the same. There's nothing I can do with that. And the bottom would be the square root of y squared, which is y. Okay, let's try number 11. Same process. Whatever the denominator is, that's what you're going to multiply whenever there's a radical in the denominator and you can't divide it. And you can't divide, this may look like you can divide it because this is 6 divided by 2, but because this is not in a radical, you can't divide that. So we must do the same process. So I'm going to multiply both of these by radical 2x and multiply this by radical 2x. When I do that, remember this is a coefficient, so the 6 has to stay on the outside. You can't put it with the 2x. So it'd be 6, 2x, and then radical 4x squared. So now what can I do? I can simplify the denominator, so the numerator stays the same, and I would get the square root of 4, which is 2, the square root of x squared, which is x. Now look, I have a fraction that I can simplify. 6 divided by 2 is 3, or 3 over 1, so I do 3 radical 2x over 1x, and we usually don't write the 1. And this is going to be the simplified form. Last one, you should know what to do, so if you want to pause it or fast forward me, that's fine. So you're going to multiply by the square root of 6x on the top and the bottom. On the top, again, you can't combine those, so the coefficient stays on the outside and the radicand stays inside the radical. And then you would get the square root of 36x squared. All right, simplify this. The top again stays the same, and the bottom you would get 6x. And then again, I must reduce because this is a fraction, so it reduces to 1/2. So I usually don't write the 1 in front of the 6x, but you can if you would like. So that's just a 1, and then on the bottom I would have 2x. So that would be my answer. All right, I'm sure you're ready for homework. Have a great day. Thanks for watching.